Next topic is using the Poisson distribution as an approximation to binomial distribution. Sometimes we can apply the formula of Poisson distribution as an approximation to the binomial distribution. In this case, if the condition is that the number of trials n is greater than or equal to 20 and the probability of success p is less than or equal to 0.05, we can use Poisson distribution instead of a binomial formula. So the Poisson formula will look like n into p raised to power x into e raised to power minus n into p divided by x factorial, where n is the number of trials that must be greater than or equal to 20 and p is the probability of success in a binomial trial that must be less than or equal to 0.05. So we can use Poisson formula instead of a binomial formula, and our Poisson mu or lambda, that is the mean, will be equal to n into p. So if you need to calculate the binomial probability with the number of trials n greater than or equal to 20 and probability of success p less than or equal to 0.05, you can use the equation for the Poisson distribution to approximate the binomial probability. So if the question is of binomial probability and these conditions are met and it is asked to use the approximation, then you can use this formula of Poisson distribution instead of the binomial distribution, where NP will replace the mu or lambda of the Poisson distribution. An example has been given where the Poisson distribution or Poisson formula has been used. You can see is in the book. Different Poisson probability distribution with a different mean will have a different histograms showing the probability. So for each different mu or lambda or average of the Poisson distribution, there will be a different histogram showing the different probabilities for 0, 1, 2 and so other number of occurrences. So here is the exercise and you will use your knowledge to solve these exercise. The answer and discussion are given at the end of the book.